So again, we have a quadratic inequality. If I distribute that negative 3, I get negative 8x less than or equal to negative 3x squared plus 3. I'll make one side equal to 0. I'm going to move everything to the left side. So I'm going to add 3x squared to both sides. I'm going to subtract 3 on both sides. That makes one side equal to 0. Again, we're going to try factoring first. It would have to be 3x and x. Is there any way, with the last one being a 3, should I do 1 and 3 or 3 and 1 to make 8? Think about it. It'll work. If we do 3 in the second one, why does that work? Now we can't just use 3 and 1 because yes, 3 and 1 never make 8. But with a 3 in the second one, the outside becomes 3 times 3, which is 9. Make the 3 negative, 1 positive. Multiply it out quickly in your head just to check. Sure enough, it works. So we get our critical values at 3 and negative 1/3. Let's look at our graph. We've got 3 and negative 1/3 as our two x-intercepts. Which way does our graph open? Down if we're looking at the first part here, but when we made it equal to 0, so this is where we're going to want to look, is once we got it equal to 0, it's actually opening up, right? So now, when we go to write our solution, we want to find out when is it less than 0. That would be this section here. So our solution is that x is between negative 1/3 and 3. Or you could write this as interval notation. Now it would be square brackets. Our smallest value is negative 1/3. Our largest value is 3. We use these ones when the value is included. So in other words, these critical values, that's when it's equal to 0 and the question says equal to 0 is okay. So when it's like it's part of the solution, we use square brackets. And because it can equal 0, then those values would be included. As a number line, okay, as a number line, you would have negative 1/3 and 3. This time your circles would be filled in because they're included. I'm going to quickly do test values for the number line just to check. A number less than negative 1/3 would be negative 1. When I plug in negative 1 into my equation, and I'm going to use the factored part, can you see in the first set of brackets, when I plug in a negative 1, I'd get negative 3 plus 1, which would be a negative number, negative 2. I'm not even going to worry about negative 2. I'm just going to remember that it's negative. And when I plug in negative 1 here, negative 1 minus 3 is negative 4. That's negative. A negative times a negative is positive. Is that less than or equal to 0? False. If I were to plug in 0, something in the middle section, this will be positive. This will be negative. Positive times a negative is a negative. Is a negative number less than or equal to 0? Yes. This section is true. And finally, if I try a number bigger than 3, like 7,432, then when I plug it in here, I'm going to get a positive number here, and I'm going to get a positive number there, and a positive times positive is positive. Is that less than or equal to 0? False. So we know that our solution on our number line is in between there, which of course, we could easily see from the graph. So the graph provides us a quicker way of seeing it, but it's still important to know how the test values work, because you're going to need to use that quite a bit in calculus. And if you take calculus next year, then I'm going to say, remember in grade 11. Okay? So take a moment to remember, and then you'll be set for next year. Okay, the questions for this one. 7 and 11. 7-Eleven Slurpees. Yes. And there's not a lot of space right under it, but there's space on the other side to write this one. So I don't see an equation, I see a word problem. When I see a word problem, I like to draw pictures, things that help me see and solve it. The length of a rectangle is 3 meters greater than twice its width. Okay. How do I write this down? There's my rectangle. I have my width. I have my length. There's a relationship between the length and the width. Often you start with saying, okay, I'm going to make x my width. How long is my length? Is it just 3 more? So this is a good start. Is the length 3 more than the width? Now we read the sentence. The length of the rectangle is 3 meters greater than twice the width. This word I didn't include yet. So now how do I accomplish that? Then I put the 2 in front, because then that makes it twice the width, and then 3 more. Good. So sometimes it's good just to start off with something, even if it's not right. It's not completely right. You draw the picture, you try something, you write it down, then you check with what you've drawn to see, does it match with the words, right? I did the exact same thing when I read this first one. I just wrote x plus 3. And I didn't go back and read the question again, and I missed the twice word. But then going back, checking it, yes, it is 2x plus 3. So here we've got our rectangle. Now, the area of this rectangle is less than 55. How do you find area of a rectangle? Length times width. So area will be length times width. So that's my area. It has to be less than 55. So that creates an inequality. Can you plug in some numbers that will work? Can someone tell me a number for x that would work? 1? So if this side is 1, this side would be 5. Sure enough, that rectangle would be less than 55. 0? Is 0 make a rectangle, though? It's a good question, but I don't know if 0 would make a rectangle. Can you draw me a rectangle with one side is 0? No, that's kind of hard. Negative numbers wouldn't work. Another x value that would work would be 25. So if x is 25, then this side would be 53. And 25 times 53 is a big number. Is it less than 55? No, I don't think so. It's challenging my mental math skills. What is it, 1325? Something like that. That's what I would guess. So we have to find out what's the biggest x could be. Now if you just go through whole numbers, you might say, if I use 5 times 13 makes what? 65. 5 is too big. 4 times, this will be 8 plus 3, 11. 4 works. So 4 is the biggest whole number. But that doesn't necessarily mean that 4 is the biggest number. Maybe 4.1 works. Maybe 4.17 works. So we've got to figure out into the decimals what will work out the best. So here we go. We're going to multiply this out. That gives us 2x squared plus 3x less than 55. Step 1 was to solve this like a quadratic equation. So you make one side equal to 0. And then go to solve. I'm looking at this one, And with that 55 there, my factoring senses tell me that I think it's not going to work out nicely. Just because that's a big number. It might. But sometimes you just get a sense that if I start to try to factor this, I might take a long time. Maybe I should go directly to the quadratic formula, or maybe I should use my graphing calculator. So I'll show you both of those. We'll look at our quadratic formula first. Negative b plus or minus b squared minus 4ac divided by 2a. 110, 440, 449. And sure enough, that does not work out to a nice number. You'd have to go to your calculator anyways to plug this in. The square root of 449 is 21.1 plus or minus 3 divided by 4. So when I use the plus sign, I get 4.54. 55. I'll go one more decimal place so that the rounding's correct. And when I do the minus sign, I get negative 6.047. Now, when I think about the context of this question, I'm talking about a rectangle. I'm talking about a rectangle's length and width. Does it make sense that this one doesn't make sense, a negative number for the width? So the only answer would be 4.54. So if this side is 4.54, then if I plug that, 4.547, if I plug it into the other side, 2 times 4.547 plus 3, plus 3, I get 12.09. To the nearest tenth of a meter, this would be 4.5, and this would be 12.1. So our dimensions need to be less than 4.5 and 12.1. That's solving it using the quadratic formula. We could also graph this on our graphing calculator and find our x-intercepts that way. Again, not a bad thing to review. So what I'm going to do is I'm going to go to y equals. I'm going to type in the equation that we had, which was 2x squared plus 3x minus 55. Two x squared plus 3x minus 55. I'm going to graph that. It's a big parabola. And the key points will be these two x-intercepts. If I've got my standard window right now, so I know that my ticky marks are each going by ones, 1, 2, 3, 4, 5, 6. I can already tell, though, this is a negative 6, that won't be an important answer. Negatives don't make sense with this, so I want to find this one on the right. So I'm going to go second, calculate. I want to find a 0. I know that my 0 is between 4 and 5, because I can just count that. So when it says left bound, you can use your arrow keys to go left and right. If you can count it and see approximately where it is, and I know that it's between 4 and 5, I can just hit 4 for my left, and I'll draw an arrow at 4. And I can hit 5 for my right, and I'll draw an arrow at 5. My calculator shows the dotted lines, and yes, my x-intercept is in between there. So I can push enter one more time, and it finds it 4.547, exactly the same thing that the quadratic formula got. So you have to decide. In this case, since this is a calculator question, which is quicker for you? That's huge. Which is quicker for you, to plug it into the quadratic formula and use your calculator to find 4.5 that way, Or is it quicker to graph it in your graphing calculator and find the x-intercept that way? So that is a decision you would have to make. If on your test you decided to use your graphing calculator, draw a quick little sketch, highlight that point, okay? Label that point 4.547 to show that I used my graphing calculator to find this, so that there's some sort of, that's your work show.
Because we can't just cut and paste calculator screens.
Not yet.
Unfortunately.
Not yet. Who knows? 5 years, 2 years from now, they'll have a thing where you just take your notes on an app and just go boom and it just puts it in there.
2 years.
Maybe next class. Who knows?
2 years from now we'll have graduated.
8 and 13 are the questions you can do for this one.